So for those of you that struggled with the long division, because maybe you didn't actually master long division in elementary school, there is another type of division we could do with polynomials that is called synthetic division that's easier, but it has its limitations as well. In order to use synthetic division, you must be dividing by a linear expression, meaning the x in the denominator can only be to the first power, and the leading coefficient has to be 1. So it could be something like x minus 5, like we saw in the last example. That would be okay because we're being raised to the first power and the leading coefficient is 1. But we could not do 2x plus 3. If we were dividing by 2x plus 3, we can't do that because the leading coefficient is not 1. And we couldn't do x squared minus 4 because it's not linear. So that's the only form that works. So you might have an easier time with this, but know that it doesn't work every time. So we're going to use that same last example that we just went through because this factor that we're dividing by is linear and does have a leading coefficient of 1. So to set up the problem, first set the denominator equal to 0 and find the number. So the denominator, this is the denominator, so x minus 5 equals 0. And the number you put to find the number you put in the division box. So we're going to go ahead and do that. We're going to add 5 to both sides. So x equals 5. Great. So 5 is going to be the number we put into the division box. So next, you make sure the numerator is written in descending order. So we're going to have to make sure we put that 4x to the 5th minus 0x to the 4th minus, well, this should be a plus anyway, x cubed plus 0x squared plus 1, so that we have our 5, 4, 3, 2, x plus 1. Oh, I messed up. This should be a 0 right here, plus 0x. We don't have a linear term in here either. So we have 5, 4, 3, 2, 1, 0. We have our 4, we have our minus x cubed, and we have our plus 1, and everything else is 0. So that's our numerator, and that's the number that makes our denominator equal 0. Okay, if any terms are missing, we must fill in the 0, and finally, list only the coefficient in the division problem. Okay, so what we're going to do is we're going to write it as 4. We're just picking out the coefficients of each of these. 4, 0, negative 1, 0, 0, and 1. All right, once the problem is set up correctly, bring the leading coefficient, well, let's set up this box here. So we always put this box here and leave a line because you're going to be putting numbers in here. So you have to leave one line there and your 5 goes here. So the very first thing you do is you bring the leading coefficient down. So that becomes a 4. Okay? Now what you're going to do is multiply the number in the division box, that's your 5, with the number you just brought down and put the result in the next column. So we do 5 times 4 and we put our result right here, which is 20. Okay? And now we're going to add those two numbers together. So 0 plus 20 gives me 20. Great. Now we're going to repeat those steps all the way until we get to the end. So 5 times 20 is 100. That goes up there, right? And then we add, so that gets me 99. So 5 times 99 would be 495, right? Okay, so that goes up there. And then we add, so we get 495. Now I'm breaking out the calculator. Fabulous. So we had, let's just check and make sure we did that right. 5 times 99. We did that 495, and then we're doing that times 5, which gets me 2475. So that goes up here, 2475. Add those two together. Luckily, I'm adding by 0, so that's not a big problem. Now I have to do 5 times the 2475. And that gets me 12,375. And then we actually add those two things together. So we get 12,376. Anybody recognize that number? Let's go back and look at that example we just did. That example gave us a remainder of 12,376. This number here is actually your remainder. So what's the other piece? What are all the other numbers? The other numbers are actually the polynomial you're left with after you do your division. So what we have is our answer of 4. Let's see, that's the remainder. So that's to the 0 power, 1 power, 2 power, 3 power, 4 power. So that's x to the 4th plus 20 x to the 3rd plus 99x squared plus 495x plus 2475. So we have our 0, our 1, 2, 3, and 4, plus your remainder, which is 12,376 over what we divided by, which was x minus 5. That is a much easier way. It's called synthetic division instead of polynomial long division. And that is an easier way to do it, but remember our limitations to it. So I'm going to give you another one to try. It's a little easier numbers than these larger numbers. Okay, so we're actually going to do the divisions we did earlier because all of their denominators qualify for this. So the denominator is a leading coefficient of 1 with a power of 1, so we're set to go there. So what would make this denominator 0? Well, that would be a positive 2. So then we draw our box, and our box gives us a coefficient of 2. That's to the 3rd power. The 2nd power is negative 5. Remember, we've got to fill in zeros if there's something missing. 1st power is 3, and 0 power is 7. So there was nothing missing. So let's go ahead and bring this first one down. 2. We do our multiplication. 2 times 2 is 4. It goes here. Add them together. Negative 1. Do your multiplication. 2 times negative 1 is negative 2. Add them together. Positive 1. 2 times 1 is 2. Add them together. We get a 9. So what we actually have is remainder 0, 1st power, 2nd power. 2x squared minus x plus 1 plus our remainder of 9 over x minus 2. Let's go back and check that example when we did it earlier, and let's see if that's actually what we got for that one. This one? Sure enough, 2x squared minus x plus 1 with a remainder of the 9. Okay, so because that denominator is a leading coefficient of 1 and an exponent of 1, there's a little bit easier of a division to do. So this is an option for you. It's called synthetic division. Most of the time you probably wouldn't pick this one up until maybe pre-calc. I don't know why, because I do find it easier as well. So let's try again. So what would make the denominator 0? I see that as negative 3. Draw my box. And this time, remember, we have to fill in. We're missing a to the 1st power term, right? So we're going to put a 2, a 5, that's the squared term, and then the 1st power term is going to be 0, and then the 0 power term is 9. We bring this one down, we get a 2. Negative 3 times 2 is negative 6. Add them together, we get negative 1. Multiply, we get a 3. Add them together, we get 3. Multiply, we get negative 9. Add them together, we get 0. This one tells us we have a remainder of 0. So this is to the 0 power, 1st power, 2nd power. So 2x squared minus x plus 3 with a remainder of 0. Remember, when we have a remainder of 0, that tells us that x plus 3 is a factor of the polynomial. Okay, one more example, just to make sure we've got this process. Okay, x plus 1, what would make that equal 0? Well, if I put in a negative 1. Okay, to the 3rd power, I have a 3. To the 2nd power, I don't have a term, so I'm putting a 0. To the 1st power, I have a 5. and to the 0 power, I have a -1. Bring down the first number, multiply, -3. Add, -3. Multiply, +3. Add, 8. Multiply, -8. Add, -9. Remainder, x to the 0, x to the 1, x squared. 3x squared minus 3x plus 8 plus a remainder of 9 over x plus 1. That is your full answer. Like I said, you're more than welcome to use synthetic division, but make sure it qualifies first that you have a leading coefficient of 1 and an exponent of 1, okay? Otherwise, if we have problems that aren't like that, then you have to go through the full process of polynomial long division.